Okay, so we're going to start with something we did last class where we want to be able to make sure we can understand piecewise functions. So go ahead and take just a second and graph f of x equals 2 absolute value of x minus 2 plus 1. And if you didn't know how to do that exactly, let's look at it. This is going to be a translation 2 to the right and 1 up. And so the vertex is going to be 2 right and 1 up. Remember, the number on the outside is up or down, and the number inside is left or right, and it's backwards from what we would think. We know this number right here is going to tell us how many times it moves the first time. So over by 1, up by 2. And because it's an absolute value, we of course know that it's going to make a V shape. So we've got this constant rate of change in both directions. So this is what our absolute value graph looks like. Okay, so now that we've got that, we want to be able to write this as a piecewise defined function. And so go ahead and try on your own just for a minute to see how you can do on that. And hopefully you know that we want to break it right here. This is where x is equal to 2. And we're going to have one piece to the left of 2 right here. This is where x is less than 2. And then we're going to have another piece to the right. This piece is where x is greater than 2. And we need to come up with equations for each of them. So let's start with this first one. F of x is going to equal, and we always write it with braces. And we usually start with the one on the left. It's not wrong if we don't, but it's what we want to do. So we're going to start with this piece on the left. And so we're trying to write the equation of this linear function. And linear functions, we usually just write in slope-intercept form, y equals mx plus b, where the m is the slope and the b is the y-intercept. So the slope here, I notice we always read from left to right. And as I read from left to right, I can see that this function is decreasing. So the slope is negative 2. The y-intercept is where it crosses the y-axis, and that y-intercept is 5. And so the slope is in front of x plus the y-intercept, so y equals negative 2x plus 5. But we need a domain restriction. This function does not keep going, right? It stops right here when x is 2. And so to show this, it's only to the part that is less than 2, to the left of 2. And so we write x is less than 2. Our other function is over here. And again, we need the slope. And I see that now this time the function is increasing, and the slope is up by 2 and over by 1. So the slope this time, so for y equals mx plus b, the slope is 2. And the y-intercept's a little harder to see because this line doesn't cross the y-axis, but that's only because there's a domain restriction. If this function kept going, if it kept going in a straight line, we can see that it would cross the y-axis right here at negative 3. And so the equation should be y equals 2x minus 3. And so we already have the y equals. Here's our y equals 2x minus 3. And again, this one is only to the right side of 2. And so we write x is greater than 2. We do have a point at 2, and since they're the same, we can use either one of these functions, but we need to put an or equals to on one of them. It doesn't really matter which one. Okay, so that is our piecewise functions. Hopefully we feel good about all the things we did last class. We're going to go ahead and get rid of this. I don't know how to delete this. Never used this program before, guys. But there's a delete button somewhere. I don't know where it is. I don't know. Can I erase it? I'll just push it off the page. There it goes. It's gone. All right, next, let's see. We are going to make sure we know how to solve linear equations. And go ahead and try to solve 2x plus 3 equals 11. And hopefully everybody feels good that we're going to put a line through this. And we want to find what x is since it's being added by 3, we subtract 3. And we're left out with 2x, this goes away, equals 8. And since x is getting multiplied by 2, oh man, I keep clicking the wrong thing. We're going to divide by 2. And so x is equal to, we cancel out that, x is equal to 8 divided by 2 is 4. And we can go back in and see that 2 times 4 plus 3 is 11. 2 times 4 is 8. 8 plus 3 is 11. So that's the solution. All right, and now we've got a new type of equation that we've never done before. We want to find what x value is true for the absolute value of x equals 8. So what possible x's will make this true? And hopefully we know that absolute value turns whatever's inside of it to be positive. Okay. So for instance, if we put in x equals 8, the absolute value of 8 will be 8. And so 8 is one of the solutions. But we can also put in x is negative 8 because the absolute value of negative 8 is also positive 8. So these are the two solutions, x is 8 and x is negative 8.